This is the video for section 11.3 and it's part 2 of that section. We're going to focus today on determining for what numbers a function is discontinuous. So now I'm going to give you the function and I want to know where is it discontinuous. That's what I'm asking. At what x values? In order to do that, the first thing we're going to have to decide is for what values could there be a problem. Now, in order to do that, we're going to look for where does our piecewise, this is a piecewise function, where does it jump from one piece to the next? Now, it looks like there's a jump at x equals 0. We jump from one function to the next. And it looks like there's another one at x equals 1. We jump from one function to the next. So those are the two that we're going to look at 0 and at 1. Now, we'll go through the process that we learned yesterday, so the 3 steps. Remember, the first step is going to test f of a, so we need to find f of 0. Now, when x equals 0, when it's equal to 0, it looks like I'm using the x plus 2 function. So we'll say 0 plus 2 is 2. Now, we're going to need to test the limit. The problem is that when we're approaching from one side or the other, we're going to be at two different pieces of this graph. So we're actually going to want to split it into both those limits, from the left side and from the right side. If I'm going from the left side, remember I'm going to be going from numbers that are less than or equal less than 0. If I'm coming from the left, I'm coming from numbers that are less than 0. So that means I'm going to use the x plus 2 piece of this function. Now, if I plug the 0 in there, I can see that limit equals 2. If I'm coming from the right side, I'm coming from numbers that are bigger than 0. So that means I'm going to be down here at the second piece of this function, and that's just 2. Now, the limit as x approaches 0 of 2 is 2, and we learned that from our limit properties. Since those are the same numbers, the limit as x approaches 0 of f of x is 2. Step 3 is to make sure those are the same, and they are. So this function is continuous at 0. There's no discontinuities there. Now, we're going to go ahead and do the same thing, only we're going to check at 1. The first step would be to find what is f of 1. Now, when x equals 1, I'm going to be looking at this first. I'm going to be looking at the middle one here, when x equals 1, and that is 2. The next thing I need to check is the limit as x approaches 1. Now, again, we'll have to split this into those two limits. The first from the left and the second from the right. When I look from the left side, numbers smaller than 1, when I'm thinking about the numbers smaller than 1, I'm going to be here between 0 and 1, so it's going to be the function 2. When I'm looking at the numbers bigger than 1, or just past 1, I'm going to jump down here to the x squared plus 2 function. Now, the limit of that, when I put the 1 in there, is 3. Since those are the same, these are not the same, this limit does not exist. And since the limit does not exist, it looks like this graph is going to be discontinuous at 1. Now, if we go ahead and let's take a look now at the picture. Another option is to draw a picture and see if there's anywhere where I had to pick up my pen. When you're drawing piecewise functions, it's helpful, remember, if you have an eraser around. The first thing I'm going to graph is the x plus 2, the line y equals x plus 2. So I'm going to go up to 2 and put a dot, and the slope is 1. Now if I graph that line, it looks like this. But the key here is I want all the x's less than or equal to 0. So I'm going to erase everything at this point bigger than 0. And there's that piece of the function. Now we'll graph y equals 2. That's going to be a horizontal line. But I only want that one from 0 to 1. So from 0 to 1, which means I'm going to have to erase everything else. Let's just redraw that part in. The last one a little bit harder, the parabola, x squared plus 2. The vertex will be at 2, and I'm going to graph a parabola, so over 1 up 1 and over 2 and up 4. And that's what that parabola looks like, but I only want it for numbers bigger than 1, which means I'm going to erase most of it except for bigger than 1, which would put us right there. And notice the open circle, and the open circle is because it's not including 1. Now you can see right here at x equals 1 is where we have that discontinuity. Let's go ahead and do one more. Now, remember the first thing we're going to look for, we're trying to decide where this function is discontinuous, is we have to look for the jumps in the pieces. Where might the problems occur? It looks like there's a jump at 0 and another one at 2. So 0 and 2 are where we're going to have to check for discontinuities. Let's start with x equals 0. Remember, the first thing we need to find is f of 0. Now, when x is equal to 0, it looks like we're going to use the function 2x. So we get 0. The second thing we need to check is the limit as x approaches 0. Now, we're going to have to check it coming from both sides. From the left and from the right. Now, from the left, we're looking for numbers lower than 0. So that would be that 2x function. And it looks like the limit of 2x is going to be 0. From the right, we're looking at numbers just bigger than 0. So now we're going to use the other function, x squared plus 1. And when I put a 1 in there, or a 0 in for x, I get a 1 out. Now, those aren't the same, so the limit does not exist, which means that we have a discontinuity at x equals 0. Now, we still have to check x equals 2 because there could be more than 1. So now we'll go through the same process as at x equals 2. F of 2, if I'm going to plug a 2 in for x, I'm going to be using x squared plus 1, which is 5. I need to check my limits now. Remember, we want to check them from both sides of this function. Now, if I'm going from numbers just smaller than 2, I'm going to use the x squared plus 1 piece. If I put a 2 in there, I get out 5. If I want numbers just over 2, I'm going to use the 7 minus x piece, and I'm also going to get out 5. So the limit's 5. Those two are the same, which means that it is continuous at 2. So the only discontinuity is at x equals 0. I want you to go ahead and try to draw this graph. So go ahead and pause your video, try to draw the graph, and then check it when you're done. And actually, we'll check it when we're done tomorrow in class, and this is where we'll leave off for